Welcome back. We're up to example 3. Here we go. Is the function linear? Well, what makes something linear? If you are growing at a constant rate. Well, I can tell you right now, the increase from q of 1 to q of 2 is approximately 1200, which is not the same thing as the increase between q of 3 and q of 2, which looks to be more than 1200. Looks to be around, what is it, 1560? That in itself, I don't need to go any further. It's increasing at an increasing rate. Which means it could be exponential. How would we prove such a thing? Well, exponentials have constant ratios. So 5200 divided by 4000 should be the same thing as 6760 over 5200, which should be the same thing as 8788 over 6760. We hope, we hope, we hope, we hope, we hope. Okay? So you can check those 3 fractions in your calculator. And hope of all hopes is that it ends up being around a 30% increase. And in fact, I think they are. At least I tried to write it so they would be. So the next question is find a formula for the function. Be careful here. What's the value when t equals 0? That's my big hint to you. So for someone that writes 4,000 times 1.3 to the t, you missed it. So how am I going to find when t is 0? How am I going to find q of 0? Well, to go forward, I multiply by 1.3. What do I do to go backwards? What if I took 4,000 and divided by 1.3? Or what if I took 5,200 and divided by 1.3 twice? Or what if I took 6,760 and divided by 1.33 times? Bottom line is, it should all get you around 3,076.92, which happens to be the value of the function at the initial amount. So, q of t should be 3,076.92 times 1.3 to the t. And if you want an exact value, just do 4,000 divided by 1.3. D, how's the general linear function similar to the general exponential? I love this. I love this. I love this. I love this problem. And how are they the same? Well, they're very similar, believe it or not. With a linear function, you start with some b value, and you can begin to add m's to it over and over and over again. How many m's? Well, x m's. And that should equal your output. So how does this differ from the exponential? Any ideas? Well, good. Hopefully you said there's only one small little change, and that is in an exponential you start with a, and rather than adding m every single time, you multiply by b every single time. And how many times do I multiply by b? X times. And it should equal y. So they're very, very similar in that it's an initial amount with an operation performed on that repeatedly x times. They're different in that one operation is multiplication and the other is addition. Excellent. Next problem.